Hello folks, we are continuing with our miscellaneous exercise. We have finished 2 parts. Now it is our part 3. In the part 3, we are taking up the questions from question number 7. So let's take this question. It says, pretty simple actually. They say that let f and g be defined from R to R, be defined as f of x equal to x plus 1 and g of x equal to 2x minus 3. They ask us to find f plus g, f minus g, f by g. These are called as algebra functions, add functions, subtract functions, divide functions, and find out what the answer is. So pretty easy. As we do normal polynomials or algebraic expressions, we'll do it like that and we'll find out the values. So here they're asking us to find out what is f plus g. So let's start. Here, let's start with first f plus g. We don't define a function that way. You require a point where it will be defined, isn't it? So let's start with f plus g of x. That means it is f of x plus g of x. That's how the algebra is defined, that whenever the function is f plus g of x, it's actually f of x plus g of x. F of x we know, g of x we know, we substitute. So what happens? F of x for us, x plus 1, g of x plus for us, 2x minus 3, club. And this becomes 3x and 1 minus 3 becomes minus 2. That's all. F plus g as a function is 3x minus 2. Then they ask us, therefore, f minus g of x similarly will be f of x minus g of x. These definitions are there with us. So it is x plus 1 minus 2x minus 3. So what happens? X plus 1 minus 2x plus 3 when we open the brackets. And let's club the terms. X minus 2x, it's minus x, and 1 plus 3, it's 4. So f minus g of x by definition is minus x plus 4. That is also done. Now we will take the next one. Therefore, f by g of x. That means it's f of x by g of x. Again by algebra. So it is x plus 1 by 2x minus 3. That's all. Right. So this is what they expect out of finding out these functions. Now that was our question number 7. Let's quickly take the question number 8. In the question number 8, they give us a function which is given like this. All this. These are the elements of this function, and it's a function that is defined from z to z. And function as such, we have seen that all the functions generally they have a rule, and the rule is f of x equal to ax plus b. You have to find out a and b, determine a and b with the help of these elements, because these are elements that is there in the function. What is the meaning of this? This actually means that f of 1 is 1. Yeah, what is the meaning of this? F of 2 is 3. F of 0 is minus 1. That is the meaning. And f of minus 1 is minus 3. This is the meaning. And we use this, and that's all. The definition is there with us. So here, f of x is ax plus b. So first we start with and. Let's take any two conditions. F of 1 is 1 and f of 2 is 3. So we'll make the substitutions. F of 1 is 1 means x is 1. The meaning is that. So in the function's definition, let's put x as 1. So it will come, this will come to a into 1 plus b. See, f of x is defined like that. F of x is ax plus b. F of 1 is a into 1 plus b. So a into 1 plus b is 1. And f of 2 is a into 2 plus b. So a into 2 plus b is 3. So what comes here? A plus b is 1 and this is 2a plus b is 3. We get two such equations. We have to solve it and get the value of a and b. Quite simple. So whatever you want, if you want, you can add, you can subtract, whatever you want, you can do and solve this. Suppose if you subtract, so what will happen? You will have this cancelled. A minus 2, it's minus a. 1 minus 3, it's minus 2. Like that, a value becomes 2. Having got the a value, you can substitute it anywhere and get the b value. So you know that here also, because a plus b is 1, so a you can put it as 2, substitute it as 2. So you get the b value as 1 minus 2. The 2 will go there, it will become minus. So 1 minus 2, it will become minus 1. That way, you're getting the a and b values as 2 and minus 1. That is what they have asked us. Find out the a and b values. It's a different dimension to the function. We have not seen problems like this. It's a different dimension. It's very important. It's very important from the understanding point of view. Yeah, that's about it. Then we are going to the next question, and in the next question, again this is an important dimension. It's important from next year's point of view and from further mathematics point of view, very important. These are concepts where when we work with the examples, the concepts become really clear to us, and that is why they are really important. When they ask us to give examples, when they ask us to work with examples, things become important. And the ninth question says that R is a relation from n to n defined by R equal to, it's there on the board, R is a set of all a comma b where a and b is natural number and a equal to b squared, whether the following are true. See, this is a relation. Now, with respect to this relation, you have to check if these three conditions are true or not. See, if they are true means you have to prove it, and if they are not true, you have to give a counter example. And fortunately, luckily or unluckily in this case, all the three are false. So therefore, you have to just give counter examples as to why this doesn't happen. It's a strange relation, a equal to b squared. That means this first element should be the square of the second element, like that. So very strange relation. So okay, so let us check. First, they are asking us to check if a and a will belong to R. That means, you take any real number, both the real, but if you take the real number like 1, 1, 7, 7, 10, 10, it should belong to R. It can belong to R only if it satisfies that condition, that first element is a square of the second element. Can that happen? If you take an element like 7, 7, it will belong to R only if the first element is a square of the second element. That doesn't happen. 7 and 7, they equal, they're not squares, right? So that is why it's not possible. So let us consider. See, we are giving a counter example. Consider 2, 2. Okay, so this is your A and this is your B. Here, this 2, that is what, like A, is not equal to 2 squared. Like A should be equal to B squared. That means this B squared and this is A. They are not equal. Okay, so because they are not equal, therefore 2, 2 doesn't belong to R. And this is a counter example. Okay, whether it is belonging, no, it is not belonging. Now second counter example is a particular element will belong. Its symmetric element will also belong or not. That is the question. For example, let 4, 2 belongs to R. Are you sure it belongs to R? Yes. Why? Because if this is A and this is B, then A equal to 4 equal to B squared. Just check. This element square is the first element. So it is belonging to R. So we have ensured, yes, it is belonging to R. Now take its symmetric element. But if you take 2, 4, the first element should be the square of the second element. That's not happening. Square of the second element is 16. Is it belonging? No. But for 2, 4, 2 is not 4 squared. Right? So therefore 2, 4 doesn't belong to R. And that is a counter example for our second one, which says that if you have one element, then you should have its symmetric element also belonging. So that doesn't happen. Now for the third subpart, I think it will take some place, so we will do it on this side. A comma B is belonging, B comma C is belonging. There is a common element, this B comma C is belonging, then A comma C should belong. That is also tricky, and so we should find two elements which is belonging to R. So let us consider for the third subpart, let us consider say 16, 4 and 4, 2 belonging to R. See, it is suiting our requirement because they say that this A, B, B, C, this B should match, they should be same elements. So we are taking these two belonging to R. Now you have to ensure whether they actually belong to R or not. They do belong to R. Why? Because the first element is the square of the second element. First element is the square of the second element. So they are. If you want, you can just mention since 16 is 4 squared and 4 is 2 squared. So they are belonging to R. Now it's for us to find out AC, first element, last element, whether it's belonging to R. That means 16 comma 2, whether it belongs to R. No, because 16 is not 2 squared, but 16 comma 2 is such that 16 is not 2 squared, right? So therefore 16 comma 2 doesn't belong to R, right? And that provides a counter example that even if you have two elements which is suiting that requirement, then that AC which we are considering, that need not belong to R. Not always it happens, and this is the example which shows that this doesn't happen. So this is our part 3 video where we take up the 7, 8 and 9 questions. Now we will go to the remaining part of the thing in the next video. Thank you.